Reminder, we always have plenty we need to do. Your homework should be out in front of you. We typically start with it. I don't have a lot I need to go over with the homework, but I usually make a few comments about it regardless. You should hopefully be able to figure out where the homework is every night. If you don't know where the homework stops, just check Schoology. Whatever document I post, and whatever answers I post, that's what I expect you to do that night. But I feel like most nights you can kind of tell when 3.4 is done, because 3.5 begins. In general, how did this go last night? Super great, super not great, and ask you things. One, they did not ask you. I don't know why anybody would be talking. I don't know why anybody would be talking. They did not ask you to do interval notation at all last night. So it's fine if you didn't. Did anybody just try it on their own just to get practice? Okay. If you didn't, that's not a big deal. They did not ask you to, but it didn't hurt. We're going to see more of this stuff as the days unfold. Okay? Ones I want to talk about. One of the reasons I need you checking the homework is to see how you're doing. The other reason I want you to check is you can learn what my expectations are just by looking at my work. So I'm going to look at number 9. I solve it. I do all these wonderful things. I get J is less than 5. It is accurate. Look at my graph. I said this in class, but the answer key really reiterates that. I only need 3 numbers on a number line. I need the number where the circle's going, and I need one above, and I need one below. That is it. I don't need you to be spending 30 minutes drawing number lines with 20 different numbers on it. You can do that if you want to. I'm trying to save you a little work. So another reason I want you checking the answers is to say, oh, if this is what he's showing, then it's okay if I show it like that too. Okay? This is the bare minimum for number lines. Okay? Why do I need to see numbers above and numbers below? Because I can't have anybody doing things like this. Notice I didn't write the numbers right after 5. I did that on purpose. Okay? Why can't you do this? Because it's wrong. Okay? So I need to see one number above, one number below, and then where the circle is. If you want to include more, that's fine, but that's the bare minimum. Marshall, question.
I just wrote the interval notation because that's what you said yesterday. That was
Okay, so normally I will tell you if that's allowed. I believe they did ask for you to graph in this one, so just make sure you check the directions next time. It's not a big deal for the class. Okay? Most of these shouldn't have been too bad. The biggest pain in the butt was probably number 13. Usually people say that because you have to graph it with the 12th. Really? You didn't think that was a pain in the butt? I thought that was a pain in the butt. Okay? Because you have to divide them into 12 sections. I won't normally do that, but it does pop up occasionally. Somebody want to tell me, why does 15 have no solution? Okay, Ellie? Yes, when you simplify, you end up with 5 is greater than 6. That is a contradiction. You write no solution, you move on. You don't graph no solution. Not at all. Although I did show you yesterday there's a way to represent it. I don't know if anybody remembers. Yeah, we're gonna talk about this today. You didn't have to do that though. This one, why is it all reals? Because if you simplify, you end up with 15 is greater than or equal to 10. That is true. You write down all reals, or you write down, what did we say was the other wording for it you could do? ARN, okay? Yeah, like your Pittsburghese, ARN, okay, whatever it might be. Shopping around town looking for ARNs. Why is it all real numbers and not INS? All inequalities have IMS. Look at this one. B is less than negative 11. How many numbers are there less than negative 11? Infinite. Okay, so we can't say IMS. We say all reals or all real numbers because that's the actual solution. Same thing. You don't graph all real numbers. Don't even bother. You could write this if you felt like it. That's a good infinity. That's not as good. Okay, again, not required. I don't really care that much about the word problems. If they were great, that's awesome. If they gave you a problem, that's okay. We will talk more about them in the future. Okay? And in general, that shouldn't have been too bad. Okay, let's go to 3.5. Now remember, that's classwork. You have a classwork packet, and you have homework with the classwork. Today is a little different. It's mostly discussion-based. I would love to hear your participation as we go. It's a lot of note taking. You need to take notes as we go, and I'll direct you where to go. Yes. Okay, we're going to talk about set notation today. This is something we'll use throughout the year. What I want you to do, I know it sounds silly, as a group, I want you to complete questions 3 through 6. Go. They're not trick questions. These are not trick questions. I want you to try number 6 as well. I haven't taught it to you, but I want to see what you do with it. You have 10 seconds. Did your grade show up? Going up again? When did you check? On this? What? Oh, check now. Okay, time. These questions were not designed to fool you. Even if you had no idea what 6 was asking for, I'll bet you can figure it out. Okay? Eyes, ears, nose. What'd you say? Okay, good job. Mother, father, brother. Sister. Right. A, E. Good. Get Y out of there. I don't have time for casual vowels. If you're either in or you're out. Y is out. Okay, we don't have time for it. 6, I did not teach you, but I'll bet you might get it right just by trying it. Suppose that the universal set of coins is penny, nickel, dime, and quarter. That's it. That's the universe of coins. And let D be the set penny, quarter. They want to know what the complement of D is. I just want you to try it. Go ahead. Nickel, dime. Now, you might say, I don't know what a complement is. Well, you're going to know by the end of the day, and you might already know now. Okay, but that's actually the correct answer. Okay, we will cover all this stuff today. It's not too bad. The one thing I want to point out to you right now, does anybody notice what's surrounding all of these? Braces. Good. They're not square brackets. They're not parentheses. They are braces. They will come up today. Now, if you're like me, I've been teaching this 20 years. I can do a lot of things. Ooh, that's pretty good. That might be one. That's one of the best ones I've ever drawn. Let's save that for later. Okay. I can't draw braces. I'm not good at it. Okay. If I do this 10 more times, I'm going to get a bunch of those. So there is an option. If you're like me and you can't draw braces, do you know what you can do instead? You can do squares. But they are important, and we will talk about why they're important today. Okay, today's a lot of talking and discussion, but you can get along. Now we're going to fill in a bunch of vocab at the bottom. Okay, it's not that long. Okay, I need you to copy in a couple of your definitions right now. Natural numbers and whole numbers. Please put these at the bottom. Don't lie to me. I'm never impressed. I just am curious, how many of you have actually heard the real term natural numbers before? It's probably a few of you. Probably not many, but a few of you. Okay. If you've never heard of it, that's fine. Natural numbers are also called the counting numbers. And what are they? 1, 2, 3, 4, ... They keep going. It actually says it on the board, but we'll talk about it. Why do they call them the counting numbers? Because the odds are very good. When you learn how to count, they probably just threw number 1 at you first. Some people do learn to count by starting with 0. Okay, but the natural numbers are 1, 2, 3, 4, etc. I can already tell without looking at it, some of your notes are bad. Do you need these braces? Yes. Do you need these 3 dots? Yes. Those 3 dots mean it goes on and on. Okay. It's a very old person texting thing. I don't know if anybody's parents do that, but parents love to put dot, dot, dot at the end of text. Does anybody, their parents do that?
Oh, yeah.
Watch out for that as they get older. My parents love it. Everything my dad sends me, he's got dot, dot, dot at the end. Okay, so it keeps going. I got asked back there, what's the difference between natural numbers and whole? It actually says it. Natural numbers begin at 1. Whole numbers are the natural numbers, but they include 0. 0 is a whole number, but it's not natural. You see where we're going with this. Now, does anybody want to guess why we need the braces? Because it's coming up in a few minutes. No. They're in a set. Marshall?
Something I have no idea about, but I just looked at it. Roster board. I have no
Okay.
idea what it is. It just says.
Yes, we can also look ahead. Okay, that's it. Okay, nonetheless. Okay, it'll come up. Natural numbers, whole numbers. What's next in your list? You should definitely know what those are. Integers, whole numbers, and their opposites. You'll notice we are building out our number line. We're not getting less involved, we're getting more involved. So 0 is still an integer, and then all opposites. 1 and -1, 2 and -2, 3 and -3, yada, yada, yada. Again with the 3 dots. Just pay attention, I'm telling you, as your parents get older, the olds, they love the dot, dot, dot on the text. If I pull my dad's text up right now, it's everything.
You never use dot, dot, dot like awkward silence?
I mean, my whole life is awkward, but you know, I still know everything. Okay. Now, what's next on your list?
Irrational.
Okay. This is where you make Miss James proud. Talk with your group. What is a rational number? See if anybody can remember. Nobody look it up. Make her proud. Say, I don't remember right away, Ellie. Good job. Time! Now, I don't want examples of them. We could be listing examples of them for the rest of our lives. I want to know what they are. Anybody want to take a shot at this? Yes.
So, like, they have to be able to divide by the thing.
Oh, divide by the thing. It's actually not the worst start, but we can't write that down. Anybody else? Anybody else? Evelyn?
They're not a decimal that has, they're not like.
I don't want to know what they're not. I know. I get what you're saying. I don't want to know what they're not. I don't want thingy in there to read.
They have to turn in it.
That sounds grim.
Oh.
Marshall?
An integer or a decimal that terminates.
Yeah, we're close. You're just not getting a full definition. I'm going to give it to you, and Miss James did teach this to you. Rational numbers are any numbers that can be written as one integer over another. That is your official definition. A over B, where A and B are integers and B is not 0. Please put that down and then I will elaborate. Please put that down and then I will elaborate. A lot of you gave me examples of them, but you didn't tell me what the actual definition is. Most of what you said is legit. Terminating decimals, yeah.
What about like 1/3?
We're going to see if it's a definition. Fun fact, most of your experience is with rational numbers. Most. Do you understand to count things anymore? Is this so outdated?
Yes.
Okay,
I don't get it.
one of these days, nothing.
Says to be created.
One of these days, everything I put up there is going to be obsolete. I just don't know when that day is going to come. So there's a lot of examples of rational numbers. So is 5 rational?
Yep.
Sure, because by definition, you could write it as what? 5 over 1, or 10 over 2. Okay, so that's good. What about like -2.5?
Yes.
Because how could you write it? -5 halves. Okay, what about like 3.25? Well, that's 3 1/4, which by definition I can write as 13/4. So anything I can put in fraction form, one integer over another, is rational. Almost everything you've studied so far is rational. Exactly. Therefore, your next one, irrational numbers are any numbers that cannot be written as the quotient of integers. The one you're the most familiar with is pi. Pi is irrational. Now there's a fraction that's super duper unbelievably close to pi that you use. Do you remember it? Anybody? 22/7. But it's not actually pi. That's just an approximation. Little known fact, there were mathematicians that dedicated their entire lives to estimating pi. That's all they did. They lived and died just trying to get the next digit of pi. And they found 22/7 to be the closest. But pi itself is irrational. You cannot write pi as a fraction, and pi over 1 doesn't count. There's always that person. Okay, you can't do it. Okay, there's others out there, but still. So rational is anything that can be put in fraction form. B can't be 0 because it would be undefined. And then we go forward. Okay, what's next on your list? So, one more.
Real numbers.
Yeah, not all numbers are real. Okay, some numbers are imaginary. So real numbers, that's your last definition on that page, are the set of rational and irrational numbers. And it's irrational, not irrational. I don't know why people want to make it irrational. It's very common. There are imaginary numbers. You probably haven't seen them unless you have a sibling that's taken Algebra 2, or you've looked ahead, or maybe you look at a star. But you study them in Algebra 2, imaginary numbers. Let's not worry about them. How about we master Algebra 1 first, then we can worry about Algebra 2. Does that sound like a plan?
Yeah, we have to take the high school thingy that, like,
Get the word thingy out of there, okay? Cool. Now, there's fun little abbreviations for them. You don't need to know these, but I write them, and it's kind of nice to know what I'm writing. So you don't need to write these. Please don't. You'll be here forever. There's little symbols for them. Okay, this takes me back to college. Oh man, such good stuff. The way that you can write the set of natural numbers, not a shock. What letter are they using there? N. But the way it actually looks, as I casually swap out the batteries here, I call it Power School N. Because it looks like this. Oh yeah. Do you know what I mean by like Power School N, like a P? Yeah. So that represents the natural numbers. Whole numbers, they use W, not a shock. They use Z for integers. I always thought that was kind of interesting. Looks like this. I like that. That's actually closeness to. Why do you think they use Q for rational? Somebody in period 1 or period 2 did. Quotient. Nice job. Yep. Quotient, irrationals. The one I like to use the most is real. That is a Power School R right there. You do not need to know these symbols. And I might draw them on the board because I can. Okay, you just need to know what those things are. Okay, the next thing you're going to do is fill in that diagram. Just fill in the words. And I hope this diagram makes sense to you on the next page. Does anyone try to explain the diagram? Like, what's the main idea here? Okay, is that Dante that said that makes sense? You want to tell us why it makes sense? No. Anybody want to try to explain that diagram to us? What's the deal here? Okay, Evelyn, go ahead.
it's kind of like showing that how one can be something else, but not like how a natural number can be a whole number, but a whole number can't be a natural.
It's the square rectangle thing. Okay, a square is a rectangle, but a rectangle is not square. There are numbers that are whole but not natural. But a natural number is also whole, also an integer, also rational. Okay, give me a natural number. Give me one. Just say it. 2. 2 is a nice choice. 2 is natural. Is it whole?
Yes.
Is it an integer? Is it rational? Okay. But if I had a rational fraction like 3/4, 3/4 is rational, but it's not an integer, it's not whole, it's not natural. So hopefully the diagram makes sense. The box inside is our most specific set of numbers, natural. Okay? And then we get a little less specific as we go out. Okay, then irrational's on the right side. Now I don't love the diagram in terms of scale. It makes it look like there's way more of these than that. But you should know, because you know numbers, there's an infinite amount of those, and guess what? Infinite amount of those. Now there's one more space at the top. Good job. You should put real at the top. Good job. Put real at the top, and then that should fill the thing up. Great question. We're going to look at this now. Okay? So, we just saw a bunch of these. So these are examples of rationals, but just because you're rational doesn't mean you're an integer. Just because you're an integer doesn't mean you're whole. Okay? You're mostly familiar with rational numbers. That's not your fault. That's just what you do. Algebra is where we really start to focus on some of these irrational numbers. There's pi. That's the one you're familiar with. Some of you might have a little square root knowledge. But like the square root of 3 is irrational. If you typed it in a calculator, it's a gross, never-ending decimal, and it can't be written as a fraction. We're going to study these a lot later in the year. But not all square roots are like that. I'll bet somebody knows what the square root of 25 is. Just say it if you don't. It's 5. That's not irrational. It's actually that. Ooh, actually, is it that?
All of them.
So we'll study square roots later in the year. You do not need to worry about it now, but you do need to kind of know what these number sets are. And again, I want you to notice how they build out. Most specific, all the way out to the most general. Okay? Questions about that diagram? Imaginary numbers, they actually showed you one. Imaginary numbers are actually square roots of negative numbers. You won't study those until you get to Algebra 2. I got news for you. I taught Algebra 2 a long time. They're not as exciting as they sound, so we won't worry about them. The hype is like not justified. Okay? Okay, let's go. More vocab here. I will tell you what I need you to copy in. Told you, heavy vocab day. There are a couple ways to write sets. The first is called roster form. Have you ever heard this word before, roster? If you play fantasy football, you know about rosters because you have a fantasy football roster. Okay? Roster form is one way to write sets. I want you to write this part of the definition. Roster form lists the elements of a set within braces. That's all I want you to put down. The highlighted piece. I'm not sure if anybody figured out why braces matter. Braces matter because it's only those values, not all of the values in between. So if I write a set with 1 and 2, I write it 1, 2 inside of braces. That's it. That's my team. That's my roster. 1 and 2 and nobody else. If I want to write the multiples of 2, brace, 2, 4, 6, 8, because it does go on, and then brace. Now remember, if you can't draw braces, what are you allowed to do? No judgment, because I have to do that. But they are required. You can't do parentheses, because we actually started to learn yesterday, parentheses like mean something. Brackets mean something. Okay, so that's roster form. Roster form is, I just list everybody that's on the team, and I do it in braces. The other one's kind of weird, but you know, sometimes things are weird, we still got to do them anyway. The other is called set builder notation. It describes the properties an element must have to be included in a set. There's that definition. Asher, did you get this yet? Go on. We're going to use these terms like throughout the year. That's why I'd say there's a lot of definitions and talking. This one's kind of weird because it's not something you would ever think to do. Rather than list the players on the team, we describe what it takes to be on the team. It's not very common. The only other place you might see this outside of math class, some of these things like you might see in like programming or coding, you might see the way you write some of these things kind of outside. So if I wanted to write the multiples of 2, this is roster form. Brace, 2, 4, 6, 8, blah, 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 brace. This is what the set builder notation looks like. It's kind of weird, but you get used to it. Brace, X, this little bar. You know what this little bar means? Such that, there's only one bar. If there were 2, it could be. X, such that X is a multiple of 2, and then you're done. It's kind of strange, but all things look strange at first. Let's look at this example. It's already done for you. We're going to write T. T is the set of natural numbers that are less than 6. Roster form is the most comfortable. T equals brace. What are the natural numbers less than 6? 1, 2, 3, 4, 5. Do we include 6? No. Nope. 1, 2, 3, 4, 5. Close brace, we're done. That's it. This one looks a little wonky. May as well just show it to you. Same stuff in set builder notation. T is equal to X. What did we say this is? Such that X is a natural number, comma, X is less than 6. We're not describing the numbers as they appear. We're describing what does it take to fit. Okay, you'll get used to this. Okay, truthfully, you'll do more of this. Okay, but you get the sense of it. Okay, now there's other funky symbols you're not responsible for, but I will probably use them at some point. There's one on the board you are responsible for coming later today. I showed that one, did I not? Okay, I will never draw this one or this one probably. I might do that one just for fun. You don't need to know these, but as you move up your mathematical courses, there's a whole like language of symbols. Okay, you kind of need to know some of them. Okay, let's actually do a couple. N is the set of even natural numbers that are less than or equal to 12. Okay, let's start it. First we're going to do roster form. So we go N equals, what do we have to do since we're listing a team here? No, not bracket brace. Ooh, natural numbers. Okay, and we want the even ones. So who's going on our roster here? Just 2? 10. Are we including 12? Why? Because it says, good. End of list. End of team. That's why you'll like this form more. You just list the numbers that appear and you're good. Okay? Now we have to do set builder notation. Okay? And remember, we have to start by defining a variable. So n equals brace. I would just use x bar. So that's such that. What are the qualifications? X is
a natural number.
even, natural, comma. I chose the same color in period 2 and it's awful. And then what's the last qualifier? X is less than somebody or equal to 12. Try the one below it. Try the one below it. You're going to write that one in roster form and set builder notation.
Yeah, I can't see.
On your page. I know, that's why I changed colors. Work on the next one. Work on the next one. Work on the one below. Roster form and set builder form. Anybody like me and you can't draw the braces, so you're giving up and just do the squiggles the whole time? Join the movement, it's okay. If you can draw braces, I'm envious of you. Just can't do it. I can get like 1 out of every 20. It's 5%. So M is the set of integers greater than -1 and less than 4. Who wants to tell me who's in our roster? Who's in our roster? Anybody think they know? Sam, you want it?
Yeah,
Okay, no worries. Finn?
braces 0, 1, 2, 3.
Ding, ding, ding. -1 doesn't count because it says greater than -1. So what's the first integer after -1? 0. 1, 2, 3, and then 4 is out as well. So that's actually what you want right here. Okay. Now we do set builder notation. So we go M equals. I'm going to go x bar. So that means x such that, what kind of number is x? X is an integer, which you have to write that, unfortunately. And then, I don't know if you know how to write a compound inequality like this. I wrote it like this. You ever do stuff like that last year? A little bit. You pay attention back there? I would love to see how good our notes are, too. That's the way that I wrote it. If you want to get really fancy, which most of you probably don't, there's a shorter way to write x as an integer. It looks like this. It's so cool. I could have written it like this. That says x is an integer. Who said element over there? Look at you. X is an element of the integer. Good job. You don't need to know this. That's just me knowing things and writing them on the board just for fun. Okay? So, when you're doing this later, might you need to look back at the diagram to remind yourself of, ooh, what's a whole number, what's integer? Yeah, you might need to. Okay, but hopefully you're not doing that forever. Okay, cool. The solving is really not that bad. If we look at the next section, we just did a bunch of these yesterday. So if they solved this inequality, what did they do first? What did they do first? What did they do first? Subtract 7, landed here. What did they then do from here? Uh-oh, ding, ding, ding. What did they do? Yeah, they did it here. Most people do it here. X is greater than or equal to -2. X can be any kind of number. So typically what we do is we just write that in set builder notation and then we move on. We don't have to worry about classifying it because X can be any kind of number. Okay? This is just one review because we did a bunch of these yesterday, but I did see some mistakes. So if we were going to solve this guy, what would you do first? Subtract 9 from each side. I think we should be doing this on our notes. I kind of know what the notes are. Now, again, don't do goofy pre-algebra stuff. Don't subtract 9 and then lose this negative sign. I've seen that before. So -4n is greater than 12. Divide each side by -4. Oh, snap. Ding, ding, ding. What happens? Now, don't get so excited that you remembered to flip the sign that you forget that 12 divided by -4 is not 3, but actually, yeah, I don't know if that happens to anybody. Sometimes we get so excited for the things we remember, we make really weird, silly mistakes. N is less than -3, so that would look like this. Graphically, what kind of circle would this be? If they asked, it would be open, and it would go to the, and if we did interval notation, ooh, that's a good infinity. It would look like that. They didn't ask for it. I'm gonna hear someone in the back there, like, do I have to like move it to you guys? Okay, now you're probably not going to love the next section, but good news, it's easy. It's just not fun. Okay, so there are things called subsets. All of you collectively are a subset as a class. Each of you individually is also considered a subset. Talk with your table about like what do you think you're a subset of. Makes it sound like you're like part of an experiment, which is
maybe like all of the periods combined, or
okay, what you got for me? There's a lot of options here, by the way, but you have to be specific. You got nothing for me after all that conversation? Nothing? Bill.
all of the periods are part of algebra, and each of us are part of one period.
Okay, so as a group, you are a subset of all my classes. Period 6 is a subset of the 4 classes that I teach. What about you individually? What could you be a subset of? Okay, a lot of things. Okay, you could be a subset of the class. Okay, yeah, I guess. Okay, the entire school, all students taking Algebra 1, etc. Okay, so what does it mean to be a subset? This is going to sound wordy, which means that you might. Okay, it sounds wordy, but it's actually not that complicated. You know that a set A is a subset of a set B if each element in A is also an element in B. It sounds really complicated. Let's actually look at this example, because it's not. That's set B. -2, -1, 0, 1, 2, 3. That is set A. -1, 0, 2. They're claiming that A is a subset of B. Is that true? Because is every element in A also contained in B? -1, good. 0, good. 2, good. A is a subset of B. We could write another one too. Okay, we could make up our own. If I wanted to do subset C of B, I could pick a different set of numbers. What could I do? 1, 2, 3? It would work. What if I wrote C is 1, 2, 3, 4? No longer. Because even though 1 is good, 2 is good, 3 is good, who's keeping it from being a subset? 4. Okay? This is the way they denote it. Okay, it's kind of weird. This means A is contained in B. That pops up a little bit on your homework. Okay, A is contained in B means all of A is contained in B. So why are you a subset? You are a subset because all of the elements, you are contained, every single one, in the subset of all my students or all my classes. Okay, the empty set or the null set is the set that contains no elements. There's nothing in the empty set or the null set. There are 2 ways to indicate the empty set. You can either draw, usually it's kind of slanted, and then you put that through, or you can draw braces with nothing inside. That is it. Please don't combine them. Don't do this, because then guess what you're doing? You're putting something into the empty set, which is not a thing. So you can either do this, or you can do that. It doesn't matter. Okay? But the empty set is part of it, and the empty set is a weird one. The empty set is a subset of every single set. Yeah, it's actually kind of important. Okay? It's annoying, but sometimes the annoying things are important. The empty set is a subset of every possible set. So what are we going to be doing with this? They want all of the subsets of 3, 4, 5. How many elements are in this, 3? Well, who's a subset of everybody? Empty set. How many options are there with 1 element? 3 by itself, 4 by itself, 5 by itself. What are all of these? The options with 2. So 3 with 4, 3 with 5, 4 with 5. And then how many options are there with all of them? Just 1. These are all of the subsets of this particular one. We're going to do a couple together. You're going to do a couple on your own. So what are the subsets of P, which contains A and B? What's the first thing we should write down? Empty set. The empty set is a subset of all sets. I know it sounds weird, but it's actually true. What are the options where we have 1 element? We could have A by itself, or we could have what? B by itself. And then we can have what? That's it. Do you have to write the braces with all of them? Yes. Yes, you do. That's not like just a me thing. That's like an always thing. Okay. What about the set S, which is A, B, and C? Well, guess what our first subset is? Don't forget it. It's always the first one you should write down. Okay, how many options with 1 element now? A by itself? Come on. B by itself? C by itself. Those are all the options with 1 element. Let's do the options with 2. We've got A with B. What else? A with C. And then finally, B with C. And then we need to include A, B, and C. It's not glamorous. As long as you're good, I'm never going to give you something with like 9 elements and make you list them all. But if you're really bad, then I will. But that's not part of the point. Okay? There's 3 of them. Go ahead, try them. Try them as a group. Okay, list all the subsets. All the subsets. There's 3 of them. Come on. What? Well, yeah, if your group doesn't want to do it by itself, then give you the option.
There's no way I'm going to list these.
You're going to. It's not that many. It's really not.
I'm trying to make a bracket for all. I have to make braces for all.
I know. I have to do that too. Turns out everybody does. I I can tell some of you are struggling. I'm going to give you a hint. I really shouldn't, but I'm going to anyway. There it is. I know. I know. I mean, you know what? That's too much. You're not ready for it. Never mind. Sorry. Too much. Too much of a hint. Most of you don't get the joke. That's fine. Come on, you can list them all. This isn't that hard. They did very well with it, period 2. You can do it. All 3 of them, too. Do the A, E, I, O one. Do the one next to it. Do the one with the pets. All 3. I also hope you all understand the homework slide now. If you didn't understand it earlier, now you get the joke. You love the empty set. Oh, really? And name 3 of its elements if you're such a fan. Correct. Still has no elements in it. The first, same question. Great dog cat. It's not that long. You can do it. I promise. The first one. Let's see how much we know. There's the empty set. How many options with 1 element? A with E, with I, with O, each one. Now the trickiest one for a lot of people is how many have 2? Does anybody think they know how many subsets Dante have exactly 2? It is 6. Good job. I don't know how anybody else did it. I just do this. A with E, A with I, A with O, then I'm done with A. E with I, E with O, I'm done with those, I with O. That's what I do. Okay. Wait, it gets trickier for some people. Some people struggle with 3. Does anybody know how many have exactly 3 elements? Bella? 4 is a winner. A-E-I, A-E-O, E-I-O, A-I-O. Which leads to 1 option here with all 4. So there's actually a grand total of 16. Somebody actually noticed in period 2, I was pretty impressed. She said it flips. It goes 1, 4, 6, 4, 1. She's not wrong. It's actually the way these things work. Yeah, that's the way it works. Don't let me pass you. These ones should be quick. What should be the first on your list here? Empty set. How many options with 1 element? 3. So 0, 1, and 2. How many options with 2 elements? 3. And how many options with all of them? 1, 3, 3, 1. And then the last one, empty set. Dog, cat, and fish separately. Dog with cat, dog with fish. Cat with fish, that's my catfish. Dog, cat, fish. Same thing. 1, 3, 3, 1, grand total of 8. Are you going to get these that have like endless amounts of lists? That's not the plan. Okay, in my mind, I would be able to do something like this one. Okay, I'm not going to give you something with like 9 elements and say list all the subsets. Again, unless you're really bad, then I don't know, but that's not part of the plan. Just remember to put the empty set down first. That's the #1 mistake. It should be the first thing you put down. Okay, the last section is actually not that bad. Okay. You just need to get a little bit more vocab. If you know anything about chess, that will help. If you don't know anything about chess, we'll get you there. When working with sets, you call the largest set you are using the universal set, or the universe. I feel like that's what you need to fill in. Maybe? Universal set.
How does chess have anything to do with chess?
Oh, we didn't get to the chess problem yet. Don't worry. So when you get asked today, what did you do in school, you can say we actually defined the universe, because that's what we're going to do right now. The universe, believe it or not, is this little green, like credit card shaped kind of thing. Now you've seen it.
Wow, that's tough.
It is tough, yes, with 2 F's. Okay. The complement of a set. I had you do a complement problem without teaching them to you. I'm actually going to teach it to you now. It's easy. The complement of a set is the set of all elements in the universal set that are not in the set. Sounds complicated. It's actually not. Let's go back to the problem you did at the beginning. So when you did this problem with no instruction from me, number 6, the universal set of coins is penny, nickel, dime, and quarter. If D is the set penny, quarter, why is it nickel, dime for the complement? It's just all the other stuff. All the stuff that you didn't pick goes in and creates. Why are you whispering back there? I know I'm losing my hearing. I could hear that. Okay. And when we have penny, quarter, nickel, dime is the complement. Those are all the things not contained in our set. So if we look at this particular diagram, if I'm calling this the universe, and I have set A, the complement is all the stuff outside of A. And this is the big statement. Any set plus its complement creates the universe. Good job. What is your question?
Why is there like an apostrophe?
Great question. Okay, we're going to get to there now. How do you denote the complement? You put this, go ahead. It's 2 o'clock. You got to go. That's fine. You just go out the back and whisper and bother me more. This little apostrophe right here is how you denote complement, but we don't say A apostrophe. I don't know if anybody knows how you say it. It's actually A prime, like Amazon Prime. Okay. What? I can't hear a word you're saying, so I'm just going to move on. Okay, A prime, that's how we denote the complement. Okay? Cool. I'm going to skip that. So here's where the chess part comes in. Where are my chess players? You don't have this problem, it's just up here. Anybody know how to play chess? Ooh, a lot of you. Okay? So they have a little cheat sheet. It's up here. I said that. I'll say it again. It's only up here. So they have a little cheat sheet, but without the cheat sheet, can somebody describe to us how all of these pieces move? How they all move? Okay? Go ahead, Ellie. One spot in any direction. The queen.
Can move as many spaces as they want without jumping in any direction.
The queen is all powerful.
The bishop can move diagonal how many other spaces without jumping.
Okay?
The knight can move 2 spaces forward and 1 to the left or right. Or
It makes these weird L spaces. What's the only thing about the knight that the other ones don't have? What can it do? Which is weird because it's a horse. You would think that that one would not be the one that could jump over. Okay? The rook can go what?
forward, backward, or sideways, any direction.
Good. It's like the bishop, and it can't go diagonally. And the pawn can go 1 spot or 2 spots at the beginning of the game, and it can capture people like diagonally. Okay? If you have no idea, they have a little cheat sheet up there. If you know how chess pieces work, this should help. The universal set of chess pieces is king, queen, bishop, knight, rook, and pawn. That's it. If you play a chess game with any other pieces, probably not a great idea. It's probably like, a little sketchy. And set A is the set of chess pieces that move side to side. So give me a little yay or nay. Yay means it moves side to side. Nay means it doesn't. The king.
Yay.
Okay. The queen.
Yay.
It doesn't really move side to side. That was the debatable one right there. Rook. Pawn. Good. So let's look at this diagram. Hopefully this diagram makes sense to you. Look, they changed the color of the universe. It's not a green credit card shape anymore. Now it's blue. Look at that. A is my set of pieces that move side to side. King, queen, and rook. What are all these? The ones that don't. This is the complement. This is the set. What does the set and the complement create?
The
universe, always. Okay, good. Okay. That leads to the last question. I want to see who can do it. I want to see who knows their months. Okay, you're going to see if you can fill in the diagram with the appropriate things. Let's see how you do. You can work together or on your own. Nah, no numbers. Write the words. Come on. I'm seeing new levels of laser here. Yeah, we'll see who knows how many days.
July has 31.
Okay, so January does?
October has
I don't know. I have no idea.
It's almost like we just did it. Do they still have the knuckle trick? I've heard about that. Yeah, I just heard about that a few years ago.
August has 32. No, August is 32. I was at 32 as in like it was so easy. I said like
If you really can't agree on the months, then go your own way. We'll settle the score in a minute.
December has 31.
All of you should have started like this.
March is 31.
All of you should have started like that. A is the set of exactly 31 days. How do we say that other one? A prime. Like Amazon Prime. A prime is not exactly 31 days. We're going to settle the score here in a moment because some of you know everything except for the months.
Can we put the
How many does
abbreviations?
August have?
August is a lot.
Okay. All right, it's judgment time. Again, though, I don't care if you don't know the months. I mean, I kind of do. You should know that for your own sake. But this should be A. A is the months with exactly 31 days. You should fill in this A. This should be A prime. If you miss that stuff, that's easy. Easy stuff. Okay? Who's confident they can tell me what's supposed to go in set A? You've got it. No debate. No issues. Josie.
January, March, May, July, August, October, and December.
Let's see. Lot riding on this. Boom. Nailed it. Good job. That's all. I know somebody left off October earlier. It's got Halloween. That's my favorite holiday. Don't do that. Okay. Yeah. I've been told there's the knuckle trick, right? That's the thing. Where it's like, what? January. The ones in between are not 31.
Yeah.
January, February, March, April, May, June, July. But then you have to do a knuckle again, right?
You go back to the beginning, that's fine.
Or either one. August, September, October, November, December. You have to use those ones. So that's fine. Okay, cool. So, what goes in A prime? All the months that don't. That's all this stuff. February, April, June, September, sadly, the greatest month that still doesn't have 31 days. And whatever. But, if you look at both of them together, they create the universe of all months. Okay, but this is A prime. Together they make all of them. Okay. So if you were wondering earlier about the question that we started with, how do you do complements? It's actually great. Suppose the universal set of coins is penny, nickel, dime, quarter, and D is the set penny, quarter. Bada bing, bada boom. There's my complement. Nickel, dime. Which leads to our last question. We can do this in under a minute. It's actually pretty quick. Suppose the universal set of numbers is 1, 2, 3, 4, 5, a couple others, and then 8. And the universal set is given. P is 2, 4, 6, and 8. What is P prime then?
1, 3, 5.
That's it. And if you comprised P with P prime, you would get the entire universe. That's it. I know. Spectacular. So when they ask, what did you do today? You can be, no big deal. We just kind of define the universe. It was all good. Okay. We will use this stuff throughout the year. I know it's a little bit different, but when I put some of these symbols on the board, when we talk about them, they're not going to look like brand new as the year goes on. So please make sure this gets done and checked. Shouldn't be super long. We do hit some heavier stuff starting tomorrow, so make sure you come ready to rock and roll.